Hey folks, and welcome to React Roundup. This episode was originally recorded with James and I and a guest, Nikolas Burk, for React Native Radio. And when we recorded it, at the time, there were some changes that have come about since then for React Native Radio. So we decided to go ahead and release this on React Roundup for the time being. And, it may show up on React Native Radio later. But anyway, I hope you enjoy this. It's a little bit different pace and different hosts, obviously, than what you're used to. But I think you'll enjoy it. So here's the episode.
Hi everyone, welcome to another episode of React Native Radio. My name's James, and this week I'm joined by Nikolas Burk from Prisma, who's going to talk with us about making front-end developers full stack using Prisma. Nikolas, would you like to introduce yourself?
Yes, sure. Hey James, thanks for having me on the show.
Hey.
My name is Nikolas and I work at Prisma. We are a developer tools company building an open source database toolkit that we're going to talk about. And at Prisma, I lead the developer success team, where we care about educating our users and help them achieving their goals with the Prisma tools.
One of my favorite communities in programming these days is the Angular community. Every time I go to an Angular conference or meet up with some of my friends who are in the Angular community, I have a great time. And a lot of them have wound up on adventures in Angular. So if you're doing front-end development, you're looking for a way to keep current on the Angular ecosystem, and you want to have a good time listening to fun people talk about great topics related to Angular, then go check out Adventures in Angular at adventuresinangular.com.
Okay, awesome. Now, I am a bit of a database noob.
That's perfect.
Okay, cool. So I mainly do front-end stuff, and I touch databases. I use GraphQL. I've had to do little bits with sort of more common stuff like Firebase, I guess. But I'd love to know a little bit about what Prisma does and why I'm going to want it and why it's going to make my app super successful.
Yeah, so what Prisma really does, it makes it easy for application developers to work with databases, because really the entire space of databases and working with databases as a developer is quite, first it's huge, and then it's also really complex. It starts by kind of picking the database that you need, and then it goes on in how do you deploy the database, and also how do you talk to the database from your application, like how do you send queries to the database, and what does that look like in your code. So that's exactly the part that Prisma is trying to make easier, kind of helping you with these very typical development workflows. And concretely, what Prisma is doing at the moment, the way how it works today, it has two kind of main features. One is called Prisma Client, which is basically a database client that you can use to send queries to your database. So instead of writing SQL in your application code and kind of spelling out these SQL strings with a select star from user table or something like this, you would have a much nicer API of requesting data from the database with just using the Prisma client instance that you have in your code. So instead of sending a select query to the database, you could do something like prisma.user.findMany, and that'll just return a list of all the user records from the database instead of having to fiddle around with SQL or anything like that.
Okay, I mean, that makes a lot of sense. It sounds like it's going to be a good shortcut to using a database in that case.
Exactly. So it really tries to abstract away from SQL and tries to make databases more approachable for all kinds of developers, even these that have no experience with SQL. And that being said, we still want to give you all the power of your database. So we are not trying to build an abstraction that then makes you kind of lose out on any database functionality, but we really want you to be able to use the database to the full power and build that kind of abstraction that makes you productive. And of course, there will always be edge cases that we can't cover with that abstraction, but for that, we provide really good escape hatches and fallbacks for kind of dropping down to raw SQL when needed. And you still can get type safety, for example. We can talk about this as well, that with Prisma, one of our big goals is also to make all your database queries type safe. So type safety is very important to us at Prisma. So that's kind of the one part I was mentioning about the two features. That's Prisma Client, and that helps you with accessing your database. The second part is called Prisma Migrate, and that is a tool that helps you to change your database schema. I don't know if you've worked with relational databases in the past, but the first thing that you have to do when you have a relational database is you have to create your schema. That is, you have to create your tables and define the columns of the tables. You have to define what type my column has on a table and all of these things. And that you typically do using just plain SQL. You just write these imperative, create table statements. And if you've done that a couple of times, you know that these SQL statements are fairly noisy and not very kind of human friendly to read. They're really these imperative statements. You typically write them in uppercase letters. It looks like SQL is just shouting at you. And it's not just like very human friendly to read. And what Prisma introduces is a schema that is a lot more human readable. It's actually inspired by the GraphQL schema language. So if you've worked with GraphQL, then you'll have no troubles whatsoever understanding how the Prisma schema works because it looks very similar. And instead of having to write these SQL definitions for defining your tables, the way how you can do it with Prisma is just you write down your Prisma schema, the models that you need in your application, and then you can map this Prisma schema to your database, and Prisma Migrate will actually generate the required imperative SQL statements for you that are needed to achieve that state. So we actually had one user comparing Prisma Migrate to React, because like with React, you don't need to like manually kind of manipulate the DOM elements anymore that you have on a website. So what you used to be before, for example, when you used a library like jQuery, is you manually manipulated all the DOM elements. So you really had to say, this is going to be green, and then I want to move it a little bit to the right, or like whatever you wanted to do. But then React was introduced and the render function was introduced. And with React, you really only describe the current state of an application, right? And then you call the render function, and React takes care of actually manipulating all the DOM elements for you. And in a sense, Prisma Migrate is doing the same way, because you can just kind of declare the target state of your database in the form of the Prisma schema, which is declarative. And then Prisma Migrate is going to generate the actual manipulation statements, the actual SQL statements for you, and execute them against the database.
Oh, interesting. So it basically abstracts the SQL. So you write something that's very comfortable and easy for a human to read, and in the background, secretly, it's doing all that work for you.
That's exactly it. We are abstracting away from SQL, and it's basically one goal that we have internally is that if you're using Prisma, that you don't have to use SQL anymore. So we want databases to be approachable for everyone, and SQL is just like SQL is a really impressive technology. I mean, it really has stood the test of time. It was developed in the 70s. And how many technologies do we use on a daily basis that have been developed in the 70s? Like maybe TCP IP, or like maybe it came a little bit later. But like even for those technologies, we typically build abstractions on top, right? We don't use TCP IP anymore directly. We use HTTP for communication. But with SQL, as of today, like we don't really have that great abstraction that helps developers to be productive and confident in their database workflows. And that's what we are trying to build. We are really trying to build that next generation abstraction for application developers to work with SQL, so that they don't have to operate on that low level anymore. Because that low level, on the one hand, it gives you a lot of power, right? You can do pretty much anything that the database would allow you to do. But it also comes with a lot of responsibility. That is that you have to take care that you're not shooting yourself in the foot, writing slow queries that lead to hours of debugging and costly performance bottlenecks that make like your application slow. So like really, these kinds of things are way too easy to get yourself into a situation with plain SQL, and you want to use an abstraction. So that's really like what we are trying to build, that kind of abstraction that makes you safe and productive when you're working with a database.
Oh, nice. That totally makes sense. And when you say it's a 50-year-old piece of technology now, isn't it, SQL? Which is it's remarkable insane that it exists in the way that it does today. And like
exactly. It's still the de facto standard.
Exactly. And it's a proper job. Like there is such a thing as a SQL developer. All you do is you write SQL queries. And I've done a little bit of light lifting with SQL, but they were fondly referred to as my first SQL queries. When I tried to get them into production, they were very hastily edited by a professional. And so I'm happy with abstracting away from that particular side of things.
Yeah, and I think another aspect to this is actually, so like for me personally, I was never kind of afraid of SQL. I always felt like kind of comfortable using it. But on the other hand, I also never felt like super productive and super confident. So I think these two things are really important as well. And they're also the core goals that we want to achieve with Prisma. That's like productivity and confidence. Because like even when you're a SQL expert, it's very hard to be productive when you're writing SQL inside of your application for a couple of reasons. Just it starts with you're writing SQL inside of your application as a string. And with a string, you don't get any type safety whatsoever. And like I mentioned it before, I personally am a big fan of TypeScript, like type safety, and a big proponent of TypeScript as well. And having that as kind of the factor that gives you confidence in the database queries that you write is just an awesome feeling. And that you never get with plain SQL because it's just a string. There is no extra validation for you. There is no syntax highlighting in your editor. Maybe you can add some plugins to get kind of to match these SQL strings with your SQL schema and perform some validation at build time or whatever you do. But it's all the time. You're just like adding another kind of layer to make a problem that you had before go away. So why not solve that problem inherently with the technology that you're using?
Very sensible. I mean, one of the things you mentioned earlier was about the performance of the SQL code. And it's possible to write a query that's wildly inefficient and you have to leave stuff overnight and it just becomes a nightmare. I'm sort of guessing, but with Prisma, when you write the abstracted code, does that automatically work in a way that's the most efficient? Is it capable of doing that?
Yes. So like what we do, or like the way how Prisma is architected is actually in 2 layers. So when you're using Prisma client, as I mentioned before, it's this kind of database client in JavaScript and TypeScript that you can just use inside your application. So like I want to make this concrete by an example. So let's say that you're building like a REST API on the backend and you have different kind of routes that you need to implement. And for each route, you have to talk to the database, right? Let's assume we have a GET request that goes to /user in your application, and that is supposed to return all the user records from the database. So in that route handler, the function that's invoked when there is a request coming in for that route, you would use Prisma client to request all the users from the database. And the way how Prisma client works is that it has 2 layers. One is just kind of the JavaScript and TypeScript runtime. So like Prisma client is available for JavaScript and for TypeScript. And below that is actually a query engine that is running in a side process on the same machine as your main application. So it's a query engine that's actually implemented in Rust. So it's very low level. And the query engine is taking in the requests from Prisma client from your main application. And then it's generating the SQL for that request. So the request, it starts at Prisma client. We say prisma.user.findMany to get all the users from the database. The Prisma client JavaScript layer delegates this to the Rust query engine that generates the SQL. The SQL goes to the database. The data comes back from the database to the query engine and back to Prisma client. And that query engine is, like, as I mentioned, implemented in Rust. And we have a team of, I think, by now 5 or 6 like really smart like Rust engineers whose kind of day job is to make your queries faster. So like That's really like the big benefit that you're getting with Prisma is that you don't have to do anything, but over time your queries will just be optimized further and further as we improve the query engine. So like I can't promise you that as of today you will get the most efficient queries, but like that is the entire topic of performance is certainly super important to us. And like whenever you identify a slow query that you think should be optimized, please create a GitHub issue in our main Prisma repo, and we'll be sure to look into it and optimize as much as possible. So like that query engine is basically where we are doing our own kind of query planning and query execution and trying to just find the shortest path for you to get the data that you requested.
Wow, and that sounds fantastic. You've got about a half dozen Rust engineers. How many people in total at Prisma?
We have now approached, I think, a mark of 35, like roughly 35 people. Right now, of course, we're all remote, although I think some people are slowly returning to the office, but like we can freely choose whether like we should be remote or not. And it was an interesting time over the last couple of months, especially since we grew the team quite a bit over the past year. And it's also super interesting to see how just the entire company changes, how new structures, processes, and teams evolve, and kind of being part of that entire process is also super interesting interesting and exciting.
Yeah. Do you think you're going to have more remote working in the future?
I think so. We already started talking about this internally, and like almost everyone, I think, was pretty happy with kind of the situation of being able to work from home. But some people also miss coming to the office. And I think in the future, it'll just be a lot more kind of liberal and everybody gets to choose like really what they want. So before Corona, we were a little bit more in the mindset of trying to have everyone in the office. And we did have like home office days. And it, of course, also wasn't okay to like spend a couple of days working from home if you needed to. But in general, we just encouraged everybody to work from the office. And I think that's somewhat changing in that we are just like free to work from wherever we want, basically. But if you want to go to the office, that's fine, but you don't have to.
Yeah, that's cool. I think a lot of places I'm hearing are taking a similar approach, which I think is good. It would be nice if a couple of good things come out of the back of this now.
Yeah, for sure.
How long has Prisma been trading for, and how long until you got the first iteration of this out?
This is a very interesting question. Actually, I started at Prisma already 3.5 years ago. So I've been here for quite a while. Like we were only 5 people when I started. And also when I started 3.5 years ago, our company was a different one. It wasn't yet called Prisma, but it was actually called GraphQL. And GraphQL was a backend as a service for GraphQL. So it basically allowed you to kind of define your models in a web interface. And what it would do would generate the database and a GraphQL API. That was GraphQL. But roughly 2.5 years ago, we pivoted to Prisma. And one of the main reasons for that was that we saw that with a backend as a service, we would always have a number of limitations that are very hard to lift for our users and that like just restrict the flexibility that people have when they need their backend. So a lot of people actually really liked using GraphQL. Like people really, really loved GraphQL for its ease of use. It was very easy to get your GraphQL API up and running, and that was great. But what we saw is that only very few people actually started using GraphQL in production. So a lot of people said, hey, GraphQL is so great. I used it to build this prototype in just 3 days, and now I'm going to build my own GraphQL API for the production app. And that, of course, was not kind of a foundation to build a sustainable business. And we thought, okay, what can we improve? How can we reshape the product to still help developers be productive in like backend development, but at the same time also can make for a sustainable business? And we came up with this idea of Prisma, where now solving kind of the database workflows for developers on the backend to make it more approachable for everybody to build one, basically, and still give people the flexibility that they need for all their requirements, all their use cases, like whatever they want to build. If they want to build a REST API, if they want to build a GraphQL API, gRPC API, whatever application they want to build that is written in JavaScript and TypeScript and that uses the database, like that's the people we're building for at the moment.
That's fantastic. I do love hearing stories of companies. Like so many people actually that I've spoken to since doing this show, they've all said they started making one thing and they realized that the need was just slightly different, and they just moved one way a little bit, and they ended up with the product that they're now working with, and they're all doing fantastically. So I hope the same happens with Prisma. How many active users are you getting in at the moment?
I don't know any numbers by heart, to be honest. And also we have kind of like an inherent challenge with kind of measuring this because all our tools are open source at the moment, and including kind of metrics and telemetry in open source apps is always a little bit like, it's for sure a topic where you have to be super careful to like not just ping a random server like every now and then, but like you also have to be very upfront about it. So the way how we do is actually we do have some analytics in the Prisma CLI, and we also have like a documentation page where we're very clear about what is being tracked, when it's being tracked, how you can opt out and opt in of the different things that are being tracked. That's how we approach that problem. But to be honest, I don't know any numbers by heart. I think last time we talked about it internally, I think if I recall correctly, we were around 15 or 20,000 weekly active developers is our metric. So like typically you speak of the daily active user, and we speak of weekly active developers that we are trying to derive from that telemetry in the Prisma CLI. So like that's kind of the range that we're looking at, but take it with a grain of salt because like we're also building like that metric system internally, like figure out the metrics first. And actually to your question before, I didn't quite finish answering it. So how long Prisma now has been around? In fact, after we pivoted from GraphQL to Prisma sort of 2 years ago, that was the first version of Prisma, Prisma 1, that has been the main version for kind of the past 1.5 years. And only about a month ago, we actually launched the current version that I talked about initially, called Prisma 2. We just call it Prisma by now. So that has only been around for production use for about a month. So that number that I shared is also just with respect to having been launched only a month ago.
Wow, okay. What are the highlights then of Prisma 2? There must be a couple of absolute killer features in there that you're super proud of as a company.
So I think two things that I really like. One thing is the Prisma schema that I already mentioned. And the other thing is the level of type safety that we provide when you're using TypeScript. But even if you're not using TypeScript and if you're just using JavaScript in your backend, we still include all the type definitions. So the index.d.ts files, where we have all the type definitions of Prisma Client. And so you will still get benefits like auto-completion, even if you're not using TypeScript per se. But with TypeScript, you even get this compile time validation of all of your queries. And that is really something that you don't get with any other database tool whatsoever, that all of your database queries are fully type safe. Typically, when you use more of a traditional approach, accessing a database like an object relational mapper or a query builder, you don't get full type safety, especially if you have sort of partial database queries. Assume you define a model in an object relational mapper as a class, and then typically what the object relational mapper does, it makes all of these properties on your model class optional, because it can never guarantee when you're having an instance of that model if that property actually exists. Was it actually retrieved from the database? So that's really a problem that no other database tool has solved, typing these partial database queries. And that is completely possible with Prisma. Every database queries that you send will always be completely type safe, which makes it just a breeze to refactor and gives you a whole lot of confidence when working with your application in general.
Back when functional programming was making its resurgence, I found it really interesting that a lot of people were moving over there, and it almost felt like it was on hype, and I didn't really understand the power of functional programming until I learned Elixir. Elixir is a functional programming language. It's built on the Erlang virtual machine, and it really does some interesting things and makes you build apps in a different way. But what's really fascinating about it is the speed of the applications, the ability to distribute work easily, and just how it manages the functional programming and all of the nice things about it, so that you don't have to worry about side effects and a lot of the other things that come out of functional programming. Plus, pattern matching in Elixir is a killer feature. If you're looking for a new language that you want to learn that is going to make a difference for you and give you the opportunity to challenge some of your thinking and find a new way of doing it, Elixir is a great way to go. And we have a podcast now on Elixir called Elixir Mix, and you can find that at elixirmix.com.
Nice. Okay. I mean, that sounds very compelling, actually. I suppose we should get into kind of the nitty meat of this, which is, let's supposing I'm a React Native developer, which I am, and I'm working on an app that maybe it needs some sort of back end. Maybe I've decided I want to start saving user details so people can log into my app or something like that. Why would I choose Prisma? And I know you've actually made some very, very good reasons for why I should do that already. And how sort of straightforward is it to implement that, especially looking at sort of a React Native side of things?
I really like that example, and especially I think for kind of your listeners who are React Native developers who probably don't have that much experience on the back end yet. They have an idea for an awesome app, right? They want to build this new app, but at some point they realize, hey, this needs to store some user data, as you mentioned, or maybe I need my users to communicate with each other, and the way how they do that is using the internet. So at that point, what you'll need is a backend. Right? And the backend, on a very high level, you have two different sort of choices. One is to use a backend as a service, and the other one would just be to code the backend yourself. And for the backend as a service, there actually are quite a few really compelling options. And in fact, as a React Native developer, if you just have a small hobby project, that's oftentimes enough for you, probably. But when you need a little bit more flexibility and have some custom requirements for your application, oftentimes that means that you want to integrate with another kind of third-party service, or you want to get data from an external API. You need to do some extra data validation. You need to integrate with Stripe. You need a custom authentication workflow. Like whatever that kind of custom requirement is, these are very hard to realize with backends as a service, because these backends as a service, they just provide you a box and you can't escape from that box anymore because your entire backend is inside of it. So at that point, what you need is you need to drop down and build your own backend. And that's oftentimes also a great learning experience. I know when I started like as a front end or actually mobile developer back in the day, like I always wondered, okay, like I'm just talking to these REST API routes here, but what does actually happen on the back end, right? So it's also a good learning exercise and a good learning opportunity, I think, for you to go in and start building your own backend to understand a little bit better what your colleagues writing your API actually do. So at that point, you want to build your own backend. So you have to decide, okay, what language do I write it in? For this podcast, let's just assume it's all written in Node or in TypeScript, and you will have to choose a database as well. And the most common type of database that is being used today is still relational databases. So I think Postgres at the moment is just the favorite or the most favorite like database of most application developers that want to build kind of scalable applications. A few folks using Mongo as well, which is nice, but really like relational databases are still the most common one used, and they're also just a safe bet because, like as we discussed earlier, the technology really has proven itself. Yeah. So these were a couple of decisions that you have to make. Then another decision that we can briefly talk about is also you have to decide, okay, how do you want to expose the functionality of your API to your client applications, to your React Native application? And most of the time, that's just a choice between REST and GraphQL. So really, these are the two most prominent ways of kind of building an API and exposing functionality and data of a server. So like for now, let's just assume that you're building like a REST API and that you implement these different endpoints. And now like you're there, you have kind of your like REST API application on backend, maybe with Express.js, which is a very popular HTTP library that you can use for that. And you have to implement your routes. And in these routes, you now have to talk to the database. So let's go back to that example of the like requesting a list of users. So say you have a /user endpoint and you can access that with a get and with a post and with a post put and with a delete request. So really all these CRUD operations to create, read, update, and delete data. So like for the get request handler, for example, you would have to retrieve a single user from the database. And you have a couple of options for doing that. And we've briefly mentioned a few of them already. So on a high level, you have 4 different options for talking to a database. The lowest level of abstraction that you can use is plain SQL. You just install like a database driver inside your TypeScript application, like Node.pg for Postgres, and that will allow you to write these SQL strings in your application, and you can then use the PG or like the Postgres driver to send that SQL string to the database and get the data back. But most of the time, people that are using that approach, they will probably build their own kind of data access layer on top of that. So they will typically kind of write their own classes and functions to call the underlying SQL. So they're building basically what we provide for them out of the box with Prisma Client. So like that, just as a side note, the first option you have on a very low level is plain SQL.
Okay.
And the problems with that is just that it's very hard to be productive in plain SQL and also being confident that you didn't make any typos or like anything like this. So SQL probably is not the greatest option, even if you're a SQL expert. It's very hard, like it's very easy to introduce a typo or anything and break your code. Then we're climbing up the abstraction ladder one by one. So the next level of abstraction would be a SQL query builder. And a SQL query builder, basically now, it's still effectively, you still compose SQL queries. So you still use kind of selects and joins and like all of these primitives that are provided to you by SQL. But what you don't have to do anymore is write strings, because a SQL query builder is basically a programmatic API for you to compose SQL queries. So you can say, you can call a function that's called select, and then inside there, you just determine the table against which you want to do the select statement. And then like you can compose your query like this. You kind of have like a chained API to compose your SQL query. And that's much, much better already. You don't have to write plain strings anymore, and you get this programmatic API. So that already makes you more productive, I would say, but you're still writing SQL. So all of that responsibility that we talked about initially of really understanding what you're doing, it still holds true for you. You still have to make sure that you're not messing up the queries that you're writing, and you have to know your SQL kind of. It's not an abstraction for someone that is not familiar with SQL. And like that's what you still be using when you're using a SQL query builder. Examples for this, for example, would be a tool called Next.js or Next.js or Objection.js or Massive.js. So like these are the typical kind of query builders, SQL query builders in the Node.js space. And then the highest level of abstraction is called Object Relational Mappers or ORMs. And these are tools that basically they were kind of developed in the context of object-oriented programming languages. And the whole idea is that you map the tables in your database to the classes in your programming language. So you're defining the tables in terms of classes, basically. So say you have a user table with an ID column, a name column, and an email column in your database. You would now go and create a user class, and you would add kind of the variables to it or properties to it, ID, name, and email to map it. But the big problem with that approach is that it's basically a fundamentally misguided abstraction. There is the thing called the object relational impedance mismatch, which describes the fundamental structural mismatch of data that is stored in relational databases and data that exists in object-oriented programming language. Because the way how data, and especially relations, so kind of related data and relations between different entities in your application, so say you have users and posts, the way how these relationships are represented in relational databases and object-oriented programming languages is very different. In relational databases, you use foreign keys to link from one table to another. So if you wanted to create a connection between the post table and the user table, you would have sort of like an author ID column on the post table, and that would store the ID of the user in the user table. Like that's called a foreign key. And the data inside the database is also kind of normalized, it's flat. And the structure in your object-oriented programming language, say JavaScript, is that you don't have this flat way of representing data, but rather you have the ability to nest object, right? So say you are kind of working with a user object in your application, and ideally if that user has some posts, then you would expect on that user table a posts property with an array with post objects. So that's the way how data is represented in your programming language. And that mismatch is called the object relational impedance mismatch. And it leads to a lot of trouble down the way using an ORM. So the premise of using an ORM is actually great. And the idea behind it is like very similar to what we are trying to do with Prisma. We are trying to kind of let you think in your data in terms of objects rather than in SQL. So we want you to stay in that mindset that you are in as a developer in your programming language, and save that kind of cognitive and also the practical cost of mapping the relational data to object-oriented data. But yeah, with like object relational mappers, you just have this fundamental mismatch. And if anybody's interested in it, there is a really, really good read about this topic. It's an article by Ted Neward. It's called The Vietnam of Computer Science. And he literally kind of calls object relational mapping the Vietnam of computer science, and says like it was a big mistake to even introduce that idea, because it just like in the beginning it's great, it gives you a couple of really quick benefits and quick wins, but on the long run it just is doomed to kind of bite you. And like that's where we are looking for an alternative approach with Prisma.
Cool. I should go and check that article out. That sounds really interesting. I'm guessing that the highest level of abstraction is the Prisma scheme.
Yes, indeed. And I would even say that, like, I'm not even sure if Prisma's higher than object relational mappers. I would actually say that in terms of like level of abstraction, it's it's a little bit higher than SQL query builders for sure, because we're abstracting away from SQL. If you're using Prisma, you don't have to use SQL. But on the other hand, it takes a different approach than most ORMs. And I would say that it probably is is even like a little bit lower in terms of abstraction. But that's probably, I don't even know how you would exactly like qualify that. So the important part, I think, is that both object relational mappers and Prisma, they both abstract away from SQL, and they both just let you think of your data in terms of objects which you're using every day anyway. So we don't require you to do this cognitive mapping, as I mentioned, to relational data.
Yeah, that's absolutely. I mean, everybody who does React is a JavaScript developer first and foremost and understands how objects work.
Yeah.
And having like everything just working in the same way, that is a nice thing.
Yeah, exactly.
Save a lot of time, a lot of learning.
Yeah, and that's what we're striving for, basically. It's kind of like one of our core principles as well, that, yeah, we want to let developers think in objects. It's also something that you can do with Mongo, right? So it's also their claim that like when you're using Mongo, you can also think of your data in objects and like not with SQL. And like what I find so like really compelling still about relational databases in general is just that you have a schema for your data. And that's what I'm like a little bit missing with Mongo, that you don't inherently have a schema for what your data looks like. You can define a schema with Mongoose, or like I'm sure that there are more tools to do that, but inherently when you're using Mongo, nobody protects you from getting your data into an inconsistent state. There is no guarantee whatsoever about what the data in the database actually looks like. And with relational databases, it's just very clear like what your data looks like. The data integrity is guaranteed. And that's just an important thing to be aware of. And in the same way that I'm a fan of kind of type safety, for the same reason that I'm a fan of type safety, I'm also a fan of schemas. Because like, be it with GraphQL for your API, there you have a schema for what your API operations look like, as opposed to REST, where you don't have that kind of schema. You can slap it on with Swagger or OpenAPI, but again, the technology inherently doesn't provide the schema. And that's what Prisma does, that's what GraphQL does, that's what relational databases do. So everywhere where you have a schema for what your data looks like and a system that enforces that schema, I think that's kind of the way to build scalable applications with confidence.
Yeah, I think having everything very prescribed in that way is key to keeping it just robust. You know, it's not going to sort of disintegrate as you start to expand it. You're not going to lose data in the wrong places. It's going to get away from you. I presume that GraphQL can interrogate it as well. You can actually, if you like GraphQL, you can still use that in conjunction with Prisma?
Yes, of course. So the example that I gave previously about like REST API, where you use Prisma client in your route handlers, basically the equivalent of these route handlers when you're building a GraphQL server are your resolvers. So in GraphQL, you don't have the concept of a route because you only have a single endpoint that accepts your GraphQL queries. But then these queries, they still need to kind of resolve the data that is being requested. And the way how that's done is by the developer implementing these resolver functions. And in these resolver functions, you need to tell kind of GraphQL where to get the data for a specific query from. And most of the time, this is going to be a database, could also be a REST API. So you see a lot of people wrapping their REST APIs with GraphQL. But if you're talking to a database, then it just means that you would be using Prisma client inside of your resolver functions. And that's the equivalent of using Prisma client in the route handlers of your REST API.
Okay, that does clear it up. Thank you very much.
Yeah.
I understand there are a couple of frameworks which already use Prisma and that they're out and you can use those straight away today?
Yes. So like it's actually super exciting that even during the preview phase of Prisma client, of Prisma, we went into beta officially in March. And then, as I said, we launched for general availability like only about a month ago. But before that, we had a preview phase of Prisma 2 that was running for more than a year. And already during the preview phase, we had people that are kind of looking for the next generation full stack framework, and in the Node.js like ecosystem who want to build that, we had those people kind of reach out to us and like talk about Prisma and see if that's a good fit for the full stack framework that they want to build. And at the moment, there are two really, really promising efforts to be that kind of next generation full stack framework. One is called Redwood.js, and that's actually authored by the GitHub co-founder, Tom Preston Werner. He is behind that project, and he has, I think, 2 or 3 or even 4 people who are basically working full time just on like Redwood and on that project.
That's a big name to have behind it. That's really cool. Yeah.
Exactly. And like we have regular calls with them and like we chat on Slack. So like we're also really trying to help them and understand their use cases. And so basically what Redwood gives you is it comes with kind of a combined way for like building your front end and your back end. So it's glued together from the start and you really build your application holistically. So like that's another thing for, I think, your kind of listeners to check out, like as more of a like front end focused like kind of audience. These kind of frameworks are also great gateway into building kind of a full stack application and not needing to worry about too many other details that are otherwise important when building a server-side application, because these frameworks will also try to make that as easy as possible for you and really be kind of goal-oriented towards the features that you actually want to build in your application so that you don't have to take care of all the nitty-gritty that is going on otherwise. So yeah, that's kind of Redwood.js. And the second one is called Blitz.js. And Blitz.js is interesting because actually for like Redwood, the way how it works is kind of the typical 3-tier architecture where you have a front end with React, then you have a server application that uses GraphQL, and then the database. So like you have these 3 layers. What Blitz does, it eliminates the server in that part. So you don't need GraphQL, you don't need REST in the middle, but it just basically goes back to the like Ruby on Rails times where you kind of build one application that can then be deployed and that is able to talk to the database, but also just like spit out the like HTML for your front end. And Blitz.js is based on Next.js, actually, the like front end framework from Vercel, formerly Zeit now, or Zeit, the company. So like these are 2 really exciting kind of full stack frameworks that are both using Prisma as their database layer of.
Sweet. It sounds like there's a lot going on in that case, which is great news. And even if those 2 frameworks are kind of React rather than React Native, there's certainly things that would cross over quite nicely, I imagine, as well.
Yeah, for sure. I mean, who knows? Like they're using React, as you said, and I don't know how far it is to then also be able to kind of port that to React Native and what's needed. Certainly super interesting projects. And I'm also just like following very closely like what they're doing, how far they are. Yeah, definitely worth checking out.
Awesome.
Cool. And then I'll also quickly want to mention like another framework that we are actually building internally at Prisma. So this one is a little bit different from Redwood and Blitz because it's not a full stack framework. It's actually just a backend framework for GraphQL. So I mentioned before that we as a company, we have quite a history in the GraphQL community because we came out of GraphQL. In fact, we also hosted the GraphQL Europe conference and GraphQL Conf last year. So we were always like pretty active in the GraphQL space and are also internally just big fans of GraphQL. So to help our users who want to build GraphQL servers that talk to a database, we currently build an open source library. And so that's basically an effort that is independent from the core Prisma tools that we're working on. It's actually an independent team inside of Prisma that is not part of our main engineering team, but a team that we call Prisma Labs. They also have their own GitHub organization. And the Prisma Labs team, it builds tools for the open source ecosystem, everything around Prisma. And the big project that they're working on at the moment is called Nexus. And Nexus is a GraphQL server framework that integrates with Prisma. So if you want to have kind of just an experience where you define your database schema or your Prisma schema, you write your Prisma schema, you define all the models that you need in your application, what they look like. Then with Nexus and the integration to Prisma, it's going to be very easy to stand up a GraphQL server with CRUD operations, like CRUD GraphQL operations, queries and mutations that are going to be exposed without needing much boilerplate. So really what you just have to do is you have to define what kind of queries and mutations you want to expose. So in general, there are kind of 5 main operations and like a couple of smaller ones, but the 5 main ones are just like retrieve a single entity, retrieve a list of entities, create an entity, update an entity, and delete an entity. And if you want to do these kinds of operations, It's literally kind of one line inside your GraphQL server code to enable and expose these queries and mutations to your front end. So if after all of this conversation now, you as a React Native developer came to the conclusion that for the next project where you need a backend, you want to use Prisma, and like maybe you also want to play around with GraphQL a little bit, I just totally recommend to use Prisma with Nexus and see how like easy it is to get started. And also with Nexus, you get the full type safety. With the Nexus to Prisma integration, your types are basically flowing from the database up to the GraphQL API, which is just a super nice experience. And if you then want to get the whole benefits of that, actually, I always love this idea of really end-to-end type safety. The types are flowing from the database over your API layer, a GraphQL API with a strongly typed schema, into your front end, where you could generate types for the queries in your front end using a tool like GraphQL Code Generator. And then you just have it all typed. And whenever you make a change and you maybe forgot updating something somewhere in your code, your compiler is going to yell at you and don't let you get away with this lack of attention.
Awesome. That sounds fantastic. I'll definitely check that out. Presumably we can get that from prisma.io?
Yes, that's exactly the website that you can get started with.
Okay, cool.
One of my favorite communities in programming these days is the Angular community. Every time I go to an Angular conference or meet up with some of my friends who are in the Angular community, I have a great time. And a lot of them have wound up on Adventures in Angular. So if you're doing front-end development, you're looking for a way to keep current on the Angular ecosystem, and you want to have a good time listening to fun people talk about great topics related to Angular, then go check out Adventures in Angular at adventuresinangular.com.
Well, we're pretty much out of time for this one, I think, this week. So there's just time to do some picks. What have you brought along for us this week?
All right. I have 2 picks. The first one is just a plug of the Prisma Day recordings. So we hosted our yearly user conference a couple of weeks ago. I think 2 weeks ago, and the Prisma Day recordings are all online on the Prisma YouTube channel. So if you want to learn more about Prisma and the different features we provide, also about the things like type safety or how to use it in GraphQL resolvers, then we have a lot of really nice content for you. And the second one is more of a personal one, and that's just chess, the game, playing chess. I've really gotten into chess lately. I've always played it a little bit as a kid, but just during the quarantine basically, and having the ability to play chess online, I'm just spending now a lot of time on my phone on Lichess. So if anyone wants to challenge me there for a game of chess, I'd be totally up for that. Just send me a DM on Twitter.
Nice. I had a go at chess a couple of years ago for the first time in ages, and I lost so badly so quickly. There was so much skill in it that I just did not have. I understand the mechanism, but I do not understand how to make a good play on that.
Yeah, it's really interesting. As you as you get more into it, you really realize that it's a lot about just pattern recognition and just seeing kind of the board and understanding the kind of options you have, and that's a super interesting aspect I find. So
interesting. Yeah. In a similar vein, I've been playing a lot of Scrabble recently, which
isn't not bad.
Yeah, I feel like chess is a little bit highbrow, but the Scrabble's still cool. I shied away from it for a long time. My wife is very good at it, and I've been secretly practicing for the last couple of months because I'm going to leave. I'm going to beat her. It's going to be incredible. I've refused to play for years. But that, again, the more I play it, I feel like it's not in the spirit of the game, but you just need to recognize patterns of letters and memorize a certain number of smaller, intricate words. And I think that's how you can make big leaps ahead in it. So I've been playing a lot of that recently.
And I assume your wife is not listening to the podcast, otherwise you just
she is. She's not going to listen to this. No, she doesn't listen to me in real life. She's not going to listen to this. If people want to get hold of you, where can they find you, Nikolas?
They can find me on Twitter as @Nikolas Burk, both Nikolas with a K and Burk also with a K. So that's Nikolas Burk. I'm on GitHub as well. And if you want to drop me an email, then best to reach me at burk@prisma.io.
Awesome. You can get me on Twitter as well. My handle is @SternJobname. And you can tweet us at ReactNative_RNR as well. If you've got any questions, any topics you'd like us to cover, come and give us a shout. Until next week, thanks very much.
Thank you so much for having me.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.